Hello, and welcome to a little video about Target 5A, where we're going to be graphically representing data. The way we're going to do that first is using a 5-number summary. And we get this from using a box and whisker plot. Let's talk about this box and whisker plot. There's a box in the middle, and it holds the lower quartile, the median, and the upper quartile. And then we have our whiskers on each side, which represent our maximum and minimum. Okay, now let's talk a little deeper about that. First, we have the minimum. The minimum is located on the far left of our box and whisker plot, and it will also be located on the left-hand side of our data. We always want to organize our data from smallest to largest, left to right. On the right side, we have our maximum. That's going to be the largest point of our data. Right smack in the middle, we have our median. This is the middle of all of our data. We also have Q1. This is our lower quartile. This is actually the median of the left side, or this 50% of the data on the left. We also have Q3. Q3 is our upper quartile, and this is actually the median of right side. So Q1 is the middle of the smaller portion of our data, of the smaller numbers, and Q3, our upper quartile, is the median of the larger part of our data. Now, speaking of parts of our data, each part of this box and whisker plot is 25% of our data. It always holds that, no matter how it looks. The whisker on the left holds 25%, which makes Q1, the lower quartile, a representation of the 25% mark. This left-hand side of the box also holds 25%. Well, that makes sense because the median is the middle, and that's 50%. Perfect. Then we have, I almost wrote 50. We have 25% in this part of the box, which makes Q3, the upper quartile, the 75% mark. And then we have our last whisker, which is also 25%, creating 100% of our data. Okay, and we'll talk about interquartile range in the next few problems. Well, not quite yet. All right, so number 5, we are going to write a 5-number summary for the sequence. And the first thing we need to do is rewrite it from smallest to largest. So here we go. 40, 42, 46, 48, 51, 55, 58, 66, 67, 68, and 69. Now, something that I like to do after I finish my list is I count the numbers that I wrote and the numbers in the given sequence and make sure that I have the same amount of numbers. So we should have 11 numbers for this sequence. Beautiful. Our minimum is 40. Our maximum is 69. Let's find our median. The way we find our median is by crossing off one number from each side until we get to the middle. You can also do this by, using your fingers and covering things up, but I can't show you that, so I'm going to be crossing off. Right, I'm going to cross one number off from each side until hopefully I'm left with one in the middle. And of course, I'll show you what happens when we're left with 2. Okay, so we have a median of 55. 55 is the number that's right in the middle of our whole data. Now, let's find Q1. Q1 is going to be the middle of the left half of the data. So let's do the same thing. Cross the number off from each side, and we're left with 46. One more time, but for Q3, for the right-hand side of the data, cross one off from each side. 67 is Q3. Let's do the same thing for number 6. First thing we're going to do is rearrange the data from smallest to largest. So 1, 5, 8, 10, 11, 12, 14, 17, 19, 20, 21, 22, and 23. The minimum is 1, The maximum is 23. Let's find the median. So let's cross a number off from each side. And it looks like we are left with two numbers in the middle, which is very different and very strange. Let's see what happens here. I'm missing a number. Something went wrong. What am I missing? What am I missing? What am I missing? What am I missing? 17, 19, 20. Oh, I'm not missing. I just have an extra. I'm like, something's wrong. Where did I get 21 from? I don't know. All right. So 12 and 14 should be in the middle. There we go. I guess I invented my own number. Perfect. Now, what happens when we have two numbers in the middle? Now, first of all, you could have a situation like this one where there's two whole numbers. And if I asked you what is between 12 and 14, hopefully you say 13. But unfortunately, life isn't perfect. So when we're actually doing stats, our numbers might not be this beautiful. So let me show you how to do this mathematically. You add the two numbers in the middle and divide them by 2. So that's 13. So again, you could have seen that 13 is in the middle of 12 and 14. But what if it was something else? All right, so 13 exists somewhere right here in between 12 and 14. Since 13 was not actually on our list, we're going to use 1 through 12 for Q1 and then 14 through 23 for Q3. So let's find out Q1. Crossing off 1 from each side, and again, I'm stuck with 8 and 10. Now, I know a lot of my students were able to tell me what number exists between 8 and 10, and it's 9. 8 plus 10 is 18, divided by 2 is 9. And let's do this one more time on this side. We're going to cross a number off from each end, and we're left with 2 in the middle again. So we're going to do 19 plus 20. That's 39 divided by 2 is 19.5. I did have a few students, very few, who were able to look at 19 and 20 and say, I know exactly what's in the middle. It's 19 and a half. If you're unsure, there is no shame in using the calculation that I showed you. All right, interquartile range. The interquartile range measures how far the data are spread out from the median. It is calculated by subtracting Q3 minus Q1 in the 5-number summary. A gym surveys its members about the average number of hours they spend at the gym each week. The data is recorded below, and luckily it's from smallest to largest. Let's find the interquartile range of the data. Okay, first thing we need to do is find the median. Because these numbers are tiny, I'm not going to cross them out. I'm just going to do little check marks underneath, because I don't want it to get too crazy. Oh, thank goodness, we found a median. It's 9. All right. We don't really do anything with the median, but it's nice to know that that is a number. All right, let's find the interquartile, Q1, just the lower quartile. I'm going to cross off 1 from each side. We're left with 2 5s. Now, this is going to sound like a silly question, but what is in the middle of 5 and 5? It's 5. Now, if you're not sure about that, what you can always do is do 5 plus 5 and divide it by 2. So Q1 is 5. If we ever get repeating numbers, that number is the median. Well, if we end up with 2 things that are the same, I mean. All right, let's take a look at this side. Cross 1 off from each side. Once again, we're left with 2 12s for Q3. So what's in the middle of 12 and 12? 12. And let me prove it to you mathematically. 12 plus 12 divided by 2 is 12. So 12 is our Q3. All right, let's do some subtraction. Oh, what did I do? Yes, I zoomed out too much. Okay. So we're going to do Q3 minus Q1. So that's 12 minus 7 minus 5. Oh, I gave the answer before even doing it. 12 minus 5 is 7. I got ahead of myself. All right, last one. Coach Peterson's Middletown High School football team is struggling to win games this season. He is trying to determine why his team has won only a few times this year. A table shows the points scored in the games in 2016 and 2017. Let's identify or calculate the interquartile range for each year. Now, this table ended up being actually pretty perfect because both sides are arranged in numerical order and they have the same amount of data. So if we find the median for one, we just look across to find the median for the other. Okay, let's do it. Let's find the median. I'm going to use 2016 to do that. Just putting check marks on each side, and I found the median. So the median exists right here for both sides. Okay. Next, let's find Q1. I'm going to use 2017 to do that. And it looks like it's right here. And I'm just going to look across to find it for 2016. And lastly, let's find Q3. It's at 25 for 2017 and 28 for 2016. Okay, let's calculate. For 2016, when we do Q3, sorry, I'm just setting it up, minus Q1, we get 28 minus 17. 28 minus 17 is 11. For 2017, Q3 is 25, Q1 is 17, 25 minus 17 is 8. So 2017 had a smaller interquartile range. That means the data is not as spread out as it was in 2016. Okay. If you have any questions about anything that you saw in this video or any of these problems, please feel free to contact either me or your teacher for help. Have a wonderful rest of your day. Bye!